The next texture to look at is the gradient texture, and that is a lazy or quick way to do gradients from the UV. So if I take gradient here and just drag the factor to the surface with the type linear, it's exactly the same thing as separate the UV and take the X to the surface. So if I take Shift A and then go to converter and separate XYZ like this and take the UV and then X here, you can't see any difference because it's no difference at all. The color and the factor is the same here. It's of course that you can divide that by separate it, but it will be the same in each channel here as you have in the factor. So we have different types here, and the first one I just showed you was linear. So that creates a gradient from black here, which means 0, to 1 here, which in this case is white. And the next one is quadratic, and that is just the value from the UV. I can take the UV in here because it will be the same thing. The value from the UV multiplied by itself. So if I just put in a power here, I will get the same result, and I can do it as well. So Shift A, converter, and then I select the math, and I take the power from this one and take the X, put this to 2, so it multiplies with itself, and I take it here, and you can see it's no difference. So most of these are really simple. There are a few that is a little bit harder, but most of them we go through in this course, and you could be without the gradient texture, but it's an effective and simple way to do stuff if you don't want the power in here. So the next one in the list is easing, and that is a mix between this power and just letting the X go out here, so it gets a bit softer. It's more complicated to do than these, so I have prepared all the math below here, so I just drag it up like this, so you can see how I should do it if I'm not using the gradient. So this will be exactly the same result, as you could see if I switched between the easing here and the color here. It's no difference at all. So it's what it does is that it first do this quadratic thing, and then it softens it with the linear here, and to make the contrast look good, the exaggerator take a little bit more from the power or the quadratic and a little less from the linear here. And all these formulas and everything else, it's not something that I invent. I just look at the code because Blender is an open source, so it's really easy to see these things. So now you can see, okay, I multiply by myself, multiply with 3, and then I subtract, multiply, and multiply, blah, blah, blah. And that I find here. So if I just go to the GitHub for Blender, and I just surf down to my shader nodes, I have a lot of stuff there. And for this, I have the node shader text gradient. And you can see here that for easing, then you can see that first we take the power, this is the power, multiplies the thing with itself, and that it saves in a variable called t. So then it takes 3 and multiply that with t. The f there means only that it's a float value. So then I just read that and put it into nodes. So something multiply power, okay, and I take that times 3, multiply with 3, and then I do the same with the linear part, and then I subtract it. So I can see here, okay, quadratic is like this, and diagonal is like this, and so on. So it's really easy to just follow this if you know a little bit about coding, how things are made here. And of course you can see the code for all the textures since everything is open source here. So I can just go back to Blender, and I don't have to show all the math between here because now you can see we can do it. And I just take this away and do a quick explanation of the rest here. So we have diagonal, and diagonal is exactly as just using the X and Y together. Then we get it down here. But since we would often like it to be up here, we do the normal stuff here to move the center up to the real center, so to say. So if I want this diagonal to be diagonal, I can either use the object like this, or if I use the UV, then I just press Shift A, go to converter and select vector math. I change this to be on the UV and subtract with 0.5 on both of these, and I multiply by 2, so it will be a correct value here as well, where if I compare with normal 0 to 1. So then you get the diagonal exactly as you want to, and that is also good for the spherical, because if you didn't do this math here, the spherical would not be spherical, it would be like just 1/4 of it. So in this case it's good to have it like this. Or the same goes for the quadratic sphere. Sorry for that. It's mathematically just the length, but you have put the power on it to make it more gradient here or softer. And the last one is radial, and we will go through exactly how that is created later in the course as well. But you use the arctangent to create this. It's a rather easy formula, but it can be used for so much when it comes to circular things. So if we will do a cogwheel, or if we would like to do the sun, or if we would like to do a clock or something like that, then the radial is really good to work with. But as I said, we will go through that in some of the chapters later on. So these are the different types of things that you can select in the gradient texture, and it's a very easy way to go between things, so you don't have to put in some math if you want it to be a bit smoother. Then you go just from the linear to easing, and you get a smoother value here. Okay, so that was the gradient texture and how it was built. And then I just go through the next texture in the next chapter. So see you there, and bye for now.